Assalamu alaikum wa rahmatullah. Welcome back to our chemistry class. It's time 03, prepared by Abdul Hamza. Today's class is electrolysis. Electrolysis is the chemical decomposition of compound in molten or solution using electricity. Electrolyte is an ionic compound which conduct electric current in molten or aqueous solution and being decomposed in the process. We have strong electrolyte decompose completely to form iron in molten pulp or aqueous solution. Example of strong electrolyte: we have sodium chloride, sodium hydroxide, tetrahydrosulfuric acid, HCl, and copper sulfate. Weak electrolyte decompose partially to form iron in molten or aqueous solution. Example of weak electrolyte: we have ammonia, ethanoic acid, HCl, hydrogen trioxocarbonate. We have electrode. Electrode is a rod or plate where electricity enter or leave electrolyte during the electrolysis reaction to occur at electrode. Discharge. Discharge is the removal of electron from negative ion to form atom or gain of electron by a positive ion to become atom. Then we have anode. Anode is a positive electron connected to a positive terminal of direct current source. Oxidation occur here. So in the anode, mostly positive electron when there and deposit is said to become neutral. Anode loses negative charge as electron float toward the battery, leaving the anode positively charged. This causes anode to discharge its electron here to replace lost electron, and also negative charge is attracted to positive charge. We have cathode. Cathode is negative electron connected to a negative terminal to direct current source. Reduction occurred here. So in the anode, in the cathode is negatively charged. So positive electron when there to deposit it is negative, it is positive electron to become neutral. Cathode gain negative charge as electron flow from the battery toward the cathode, making the cathode negatively charged, cause electron to be attractive and gain electron to become atom. So we have anion. Anion is a negative ion. It is attracted to anode, while cation is positive cation is attracted to a cathode. So in the law of electricity, like charges repel, while unlike charges attract. In anode is negatively charged. So since anode is negatively charged, is attracted positive electron toward itself. Cathode is positively charged. so it's attracted negative electron. So negative element attracted by cathode, by anode, which is negatively charged, while positive element attracted by cathode, which is negatively charged. So let's see the electrolysis of molten compound. So molten or aqueous ionic compound conduct electricity because ions are free to move. In solid state, ions are held in fixed position within the crystal lattice. So solid ionic compound do not conduct electricity when molten binary compound is electrolyzed. Metal move to cathode while non-metal move to anode. Electrolysis of molten lead bromide to produce molten lead 2 bromide. You strongly heat the solution until it melts. To electrolysis is fast current through the lead bromide ion. So the ion present in the solution, we have lead plus, lead 2 plus, and bromine minus. So reaction in the anode, bromine is negatively charged, loses electron to anode to become bromine atom. So bromine atom created bond together to make bromine molecule gas. So two bromine ion to form bromine gas and loses two negative electrons. So these are the reaction taking place in anode. Let's see what is the reaction taking place in cathode. So in cathode, lead is positively charged. Gain electron at cathode to become lead atom, becoming liquid lead. So this is lead 2 plus dissociate to form lead atom plus 2 positive electron. So the overall reaction is the reaction taking place in the cathode and the reaction taking place in the anode match together to form. Here in the anode, the product is only 2 bromine minus, while in the reactant side we have 2 bromine plus 2 electrons. So in the cathode we have two in the cathode in the further side we have the 2 plus 2 electrons to give lead atom. So when we match together, this lead 2 bromide plus lead plus plus bromine ion. So this is the overall reaction. Lead 2 bromide dissociate to give lead and bromine 2 ion. Let's see the electrolysis of aqueous solution. We have seen the electrolysis of molten solution. Let's see the electrolysis of aqueous solution. So aqueous solution contain additional hydrogen ion and OH ion from water, totaling 4 different ions in the solution. So in aqueous solution, we have additional of hydrogen ion and the OH ion plus the ion solution, making them 4 different ions in the solution. So 2 from electrolyte and 2 from water, where only 2 of these ions are discharged during the process of electrolysis. So this is the factors affecting the selective discharge of ion during electrolysis. Number 1, we have the concentration of the ions. Number 2, position of ion on the electrochemical series. So the lower element is on the electrochemical series, the lesser stable they are, and the more vulnerable they become to be discharged during the electrolysis. Hence, the lower cation receive electron readily to form its metal, while the more reactive ion, so metal remain in solution. Then number 3, we have the nature of electron. So these are the factors affecting the selective discharge of ion during the electrolysis. Let's see the electrolysis of concentrated sodium chloride. In the electrolysis of sodium chloride, the ion present is sodium ion, hydrogen ion, OH ion, and chlorine ion. So the sodium ion and the chlorine ion is from the sodium chloride, and the hydrogen and OH is from the water. That is the solution from the electrolysis of aqueous solution. We have seen this. So what is taking place in the anode? Chlorine ion loses electron and the anode to become chlorine ion, to become chlorine atom. Although OH is easier to discharge, the atom created form covalent bond together to make chlorine molecule gas. So this is the reaction. Chlorine ion to give dissociate to give chlorine atom plus 2 electrons. That is, the chlorine has been discharged in the anode. So reaction at the cathode. Hydrogen get electron at the cathode to become hydrogen atom, becoming hydrogen gas. The 2 molecules of hydrogen ion dissociate at the cathode to give 2 positive electrons plus hydrogen molecule. So this is the overall equation. HCl to give dissociate to give hydrogen molecule plus chlorine molecule. Note, any cation and anion left undischarged in solution form new bond between them, e.g. in above leftover, sodium ion and OH combine to form sodium hydroxide and a very dilute solution. So let us see the electrolysis of the Citriaoxosulfuric acid. Citriaoxosulfuric acid is aqueous solution also. So let us see the ion present. The ion presence are hydrogen ion, OH ion, and SO4 ion. So which of the ion will be discharged in the cathode and which one will be discharged in the anode? So the OH loses electron at anode to become oxygen molecule and water molecule. So 4 molecule of OH ion to give 2 molecule of oxygen plus H2O plus electron. So reaction at the cathode, hydrogen gain electron at cathode to become hydrogen atom, becoming hydrogen gas. So 2 molecule of hydrogen gas to give 2 electron plus hydrogen molecule. Since only water molecule is electrolyzed, the tetraoxosulfuric acid only become concentrated. Electrolysis using different types of electrode. Anode electrode. Who we say anode? We mean element or anything that doesn't have to that doesn't lead to either accept or gain anything from anybody. So in chemistry, when we say inert gas, inert are mostly gases. There is group of 8 in the periodic table. We have helium, neon, argon. So these are the example of inert. So let us see in the electrolysis. Inert electron are electrons who do not react with electrolyte or product during the electrolysis. Example are platinum and graphite. So platinum and graphite are also inert. Active electron are electrons which react with product of electrolyte, affecting the course of electrolysis. So example of active electron is copper. So electrolysis of copper sulfate using inert electron. Example, carbon. So the ion presence are copper 2 ion, hydrogen ion, OH ion, and SO4 ion. So in the reaction at the cathode, if you the OH will discharge force since OH is higher in the electrochemical series than SO4 ion. So the OH lose electron at the cathode to become oxygen molecule and water molecule. So this is a reaction OH to give oxygen and water plus electron. That is at the anode. What will happen at the cathode? Copper will gain electron at the cathode to become copper atom, becoming liquid copper. Hydrogen ion are not discharged because copper is easier to discharge, being lower in the electrochemical series. Copper 2 plus to give 2 electron plus copper atom. Since copper ion in solution are used of, the blue color PET. Hydrogen and sulfate ion left forming tetraoxosulfate 6 acid. Electrolysis of copper sulfate using active electrode. Example, copper. So when we use the active electrode, let's see what will happen in the cathode and the anode. Ion phrases are also the same as using inert electrode, which has copper 2 plus hydrogen ion and SO4. So at the anode, both SO4 and OH get attracted here, but not discharged. Instead of copper, anode is discharged by losing electron to form copper 2 ion. So electron size decrease. So this is a reaction. Copper to give copper 2 plus 2 electron. So this is a reaction taking place in the anode. While in the cathode, copper 2 ion produces from anode get electron and the cathode to become copper atom, becoming copper. Hence the copper is deposited there and the electron increase in size. So make sure you have to understand this. Electrolysis of copper 2 sulfate using active electrode. The reaction taking place in the anode. Please know the reaction taking place in the anode and the reaction taking place in the cathode. In the anode, copper 2 ion decreases in charge, in size, while in the cathode, copper 2 ion increases in size. So these are the things you're supposed to be know. Overall change, there is no change in solution contained as for every loss of copper 2 ion at the cathode is replaced by copper 2 ion released by dissolving anode. Only the cathode increases in size by gaining copper metal, and anode decreases in size by losing copper. So we can use this method to create pure copper on cathode by using pure copper on anode and impure copper on anode. Impurities in the anode felt off under it. Electroplating is coating of object with thin layer of metal by electrolysis. This makes object protected and more attractive. Object to be plated is made to be cathode, and the plating metal is made at the anode. The electrolyte must contain plating metal cation. Example, plated iron object with nickel. So reaction at the cathode, nickel ion discharge from the anode into a solution, so the electron size decreases. So these are the nickel atom associated to give nickel atom dissociate to give nickel ion plus electron. Reaction at the cathode, nickel ion produced from the anode gain electron and the cathode to become nickel atom, becoming nickel. Hence, the nickel is deposited here and the electron grow. So this is the reaction. Nickel ion dissociate to give nickel atom plus electron. Overall change, there is no change in solution content while ion subject receive nickel deposited. Uses of electroplating: chromium, water tap motor, car bumpers, bicycle fan, tin can, silver spoon, trophies, plate, ornament, cutleries, nickel form, corrosion resistant layer, gold, watch flag, water tap, silverware, jewelry, watch, copper, printed circuit board. So all these are using in electroplating, like necklace or necklace. It can be used to plate gold in it. So electroplating are used in different ways. So this is the end of today's lecture. We shall meet in the next class. Thank you for listening.